Alright, typecasting. Typecasting is a way to check the type of an instance or to treat that instance as a different superclass or subclass from somewhere else in its own class hierarchy. Typecasting in Swift is implemented with the is and as operators. These two operators provide a simple and expressive way to check the type of a value or cast a value to a different type. You can also use typecasting to check whether a type conforms to a protocol as described in checking for protocol conformance, defining a class hierarchy for typecasting. You can use typecasting with a hierarchy of classes and subclasses to check the type of a particular class instance and to cast that instance to another class within the same hierarchy. The three code snippets below define a hierarchy of classes and an array containing instances of those classes for use in an example of typecasting. The first snippet defines a new base class called media item. This class provides basic functionality for any kind of item that appears in the digital media library. Specifically, it declares a name property of type string and an init name initializer. It is assumed that all media items, including all movies and songs, will have a name. So class media item. Var name is a string. Init is a method which takes name as a string and assigns self.name equals to name. The next snippet defines two subclasses of media item. The first subclass, movie, encapsulates additional information about a movie or film. It adds a director property on top of the base media item class with a corresponding initializer. The second subclass, song, adds an artist property and initializer on top of the base class. So here's the movie class, which extends media item. It adds a director string, and init is rewritten as a name and a director string, and self.director becomes director. Super.init takes name, name. So we're going to call the parent classes in it, and we're going to also assign self.director. Now the song class extends media item as well and has a var artist, which is a string, calls the superclass in it, and self.artist gets assigned to artist in the same way as the movie. The final snippet creates a constant array called library, which contains two movie instances and three song instances. The type of the library array is inferred by initializing it with the contents of an array literal. Swift's type checker is able to deduce that movie and song and have a common superclass of media item, and so it infers a type of media item for the library array. So let library equals an array of movies and songs here, where we pass in name of and director or name and artist. And Swift is smart enough to realize that they both have the same superclass media item. So the items stored in library are still movie and song instances behind the scenes. However, if you iterate over the contents of this array, the items you receive back are typed as media item and not as movie or song. In order to work with them as their native type, you need to check their type or downcast them to a different type as described below. Checking type. Use the type operator, check operator is, to check whether an instance is of a certain subclass type. The type check operator returns true if the instance of the subclass type and false if it's not. The example below defines two variables, movie count and song count, which count the number of movie and song instances in the library array. Var movie count is 0, var song count is 0. For item in library, if item is movie, movie count plus equals 1. Else, if item is song, song count plus equals 1. Print. Media library contains movie count movies and song count songs. So print media library contains 2 movies and 3 songs. This example iterates through all the items in the library array. On each pass, the for in loop sets the item constant to the next media item in the array. Item is the movie returns true if the current media item is a movie instance and false if it's not. Similarly, item is song checks whether the item is a song instance. At the end of the for in loop, the values of movie count and song count contain a count of how many media item instances were found for each type. So this is called checking the type and is done by using the is operator. Now, downcasting. A constant or variable of a certain class type may actually refer to an instance of a subclass behind the scenes. Where you believe this is the case, you can try to downcast to the subclass type with a typecast operator as ? Or as ! Because downcasting can fail, the typecast operator comes in two forms. The conditional form, as ? returns an optional value of the type you are trying to downcast to. The forced form, as ! attempts the downcast and force unwraps the result as a single compound action. Use the conditional form when you're not sure if the downcast will succeed. This form of the operator will always return an optional value, and the value will be nil if the downcast was not possible. This enables you to check for a successful downcast. Use the forced form of the typecast operator as ! only when you're sure that the downcast will always succeed. This form of the operator will trigger a runtime error if you try to downcast to an incorrect class type. The example below iterates over each media item in the library and prints an appropriate description for each item. To do this, it needs to access each item as a true movie or song and not just as a media item. This is necessary in order for it to be able to access the director or artist property of a movie or song for use in the description. In this example, each item in the array might be a movie or it might be a song. You don't know in advance which actual class to use for each item, and so it's appropriate to use the conditional form of the typecast operator as ? to check the downcast each time through the loop. So for item in library, if let movie equals item as ? movie, then print the movie name, director, movie director. Else if let song equals item as song, then print the song name by song.artists. So we're basically downcasting the movie item or media item and into a movie or a song. We don't know which one it will be, so we're using a optional. And once we downcast it, then if it succeeds, we've learned about the if let operator in our lecture on optionals. So if let movie equals item as movie, so then we will be able to print the movie name and movie director. So the result will be for the 5 things, the 2 movies and the 3 songs. The example starts by trying to downcast the current item as movie because item is a media item instance. It's possible that it might be a movie. Equally, it's also possible that it might be a song or even just a base media item. Because of the uncertainty, the as ? optional form of the typecast operator returns the optional value when attempting to downcast to a subclass type. The result of item as ? movie is of type movie ? or an optional movie. And the if-let syntax allows us to unpack the optional movie into just movie. And that's called optional binding, which I talked about in my lecture on optionals. Try to access item as a movie. If this is successful, set a new temporary constant called movie to the value stored in the returned optional movie. If the downcasting succeeds, the properties of movie are then used to print a description for that movie instance, including the name of its director. A similar principle is used to check for songs instances and to print an appropriate description, including the artist name whenever a song is found in the library. Note, casting does not actually modify the instance or change its values. The underlying instance remains the same, it's simply treated and accessed as an instance of the type to which it has been cast. Typecasting for any and any object. Swift provides two special types for working with non-specific types. Any can represent an instance of any type at all, including function types. Any object can represent an instance of any class type. So use any and any object only when you explicitly need the behavior and capabilities they provide. It's always better to be specific about the types you expect to work with in your code. Here's an example of using any to work with a mix of different types, including function types and non-class types. The examples create an array of called things, which can store values of type any. So we'll create a var things, which is an array of any. And then we will append 0 and append 0.0. Things.append 42, things.append 3.14, things.append hello, things.append an array 3.0, 5.0, things.append movie, name Ghostbusters, director Eamon Reitman, things.append name string goes to string in hello name. So all kinds of things have been contained here. So the things array contains two int values, two double values, a string value, a tuple of type double. The movie Ghostbusters, and a closure expression that takes a string value and returns another string value. So note that 3.0, 5.0 was a tuple, and the last one was a closure, which takes a string and returns hello with that string. So to discover the specific type of a constant or variable that is known only to be of type any or any object, you can use an is or as pattern in a switch statement cases. For example, below iterates over the items in the things array and queries the type of each item with a switch statement. Several of the switch statements cases bind their matched value to a constant of the specified type to enable its value to be printed. So for thing in things, switch over the thing. Case 0 as int, print 0 and as an int. Case 0 as double, print 0 as a double. Case let sum int as int, an integer value of sum int. Case let sum double as double, where sum double is greater than 0, colon, print, open parentheses, quote, a positive double value of backslash, open parentheses, sum double, close parentheses, quote, close parentheses. Case is double, print sum double. Case let some string as string, xy is some double tuple. Case let movie as movie. Case let string converter as string goes to string. Print string converter Michael. Default something else. Okay. Note any type represents a values of any type, including optional types. Swift gives you a warning. If you use an optional value where a value of type any is expected. If you really do need to use an optional value as an any value, you can use the as operator to explicitly cast the optional to any, as shown below. Okay. That's it for this tutorial on typecasting.